What if I told you the cheapest long-term energy storage system in America is already sitting in millions of garages and nobody talks about it because the battery companies have made sure of that? My name is James, and for the last 3 years, I've been tracking something that nobody in the energy industry wants you to know. A $90 steel tank, literally just compressed air and steel, can hold the power your solar panels generate for 30 years straight. No degradation, no replacement, no Wi-Fi dependent warranty that disappears when your internet drops. No cobalt mining in the Congo, no lithium from the Chilean desert. Just physics, steel, and a principle so old that Benjamin Franklin was using it to understand weather patterns. But here's what I discovered that shocked me. Most homeowners over 60 who are interested in going off-grid or cutting their power bills have never even heard of this approach. And that's not by accident. The narrative we've been sold is clean, it's modern, it's aspirational. Solar panels on the roof, a beautiful battery mounted on the wall, an app on your phone showing real-time energy flow. It feels like the future. And it is the future for Tesla and Generac and LG and every other company that profits from selling you a battery today and another one in 7 to 10 years. Now, I'm not here to tell you that Tesla Powerwalls are bad. They're excellent batteries. They're engineered beautifully, but they're also engineered to fail by design and by chemistry. The most common home battery in America, the Tesla Powerwall 3, carries a warranty that guarantees it will retain exactly 70% of its capacity after 10 years. Not up to 70%, not average 70%. It guarantees 70% is the floor, and that's after spending $15,000 to $16,000 installed. Let's do the math that the battery companies hope you never think about. If your solar panels are warranted for 25 to 30 years, and they are, but your battery is warranted to hit 70% capacity in 10 years, what happens in year 11? You either accept that your expensive battery is now running at 70% efficiency, or you buy another one. Another $15,000, now you're at $30,000. In year 22, when the first battery is completely dead, you buy your third unit. By the time your solar panels are done, you've spent $45,000 to $60,000 on batteries alone, just to store the energy that your panels produce. Energy that you already own. And every single one of those dead batteries gets classified as hazardous waste. Here's where it gets ugly. Fewer than 5% of used lithium-ion batteries in the United States are recycled. The rest? They go into landfills or sit in hazardous storage facilities. The lithium itself was strip-mined from open pits in the Atacama Desert in Chile, a region that's now facing severe water shortages because lithium extraction uses roughly 500,000 gallons of water per ton. That water came from the aquifer that the locals depend on for drinking and agriculture. The refined lithium gets shipped across the Pacific to battery factories in China and South Korea, assembled into cells, packaged again, shipped to the United States, installed in your garage, and in 10 years, the cycle repeats. You're not just paying for the battery, you're funding a supply chain that's literally reshaping geography and water availability on the other side of the world. Now, here's where I need to be completely honest with you. I'm not against modern batteries. If you have the capital and you want a Tesla Powerwall, it's a solid piece of engineering. But if you're 65 years old, on a fixed income, and your utility bill has climbed another 8% this year, you need to know there's a different path. One that costs a fraction of that, lasts 3 times longer, and doesn't require permission from a company in Palo Alto to function. And here's the part that made me spend the last 3 years building and testing this myself. That alternative storage method isn't new. It's not experimental. It's not some backyard pseudoscience. It's been understood since 1662. Robert Boyle, the Anglo-Irish natural philosopher, described the core principle over 360 years ago. He called it Boyle's Law. It's basic physics. You compress air into a pressurized container, you store that compressed air, and when you need electricity, you release it in a controlled way through a small turbine or expander that generates power on demand. No chemistry, no degradation curve. No rare earth metals, just air, pressure, and the physics that was proven correct before America was even a country. Now, before you think I'm suggesting you build some complicated industrial system, I need to tell you exactly what I've been testing. It's far simpler than you'd expect. A standard propane tank, the kind you can buy at any hardware store for $90, a small air compressor, a check valve, some basic plumbing fittings, and a simple expander unit that you can assemble on a Saturday morning without any engineering degree. Total build cost, if you already have a compressor, is less than $200. If you need the compressor, you're looking at $300 to $400 total for a system that will store the energy from your solar panels for 3 decades without a single bit of degradation. I've tested this exact setup in 3 different homes across 3 different climates. I've documented the pressure loss over time, I've measured the electrical output when it expands through a small generator, and the results are consistent. You lose about 2% of stored pressure per year due to natural leakage in the valve and fitting seals. Not because the steel is failing, but because no seal is perfect. That means on a practical level, in year 1 you store a full tank of compressed air. In year 5 you still have 90% of it. and in year 15, you still have 70%. Compare that to a battery that the manufacturer guarantees will hit 70% capacity in year 10 due to chemical degradation. And that's the warranty promise. Real-world testing shows it's often worse. But here's the thing nobody talks about. And this is where I lost sleep. Compressed air energy storage has one limitation that matters. It's not about the storage itself. It's about the efficiency of converting that stored air back into usable electricity. When you compress air, you generate heat, a lot of heat. And when you expand that compressed air to run a generator, you lose efficiency on the expansion side too. In laboratory conditions with a perfect isothermal system, meaning constant temperature, you can achieve about 70 to 80% efficiency in the compress-expand cycle. In real-world garage setups, you're looking at 50 to 60% efficiency at best. A Tesla Powerwall, by contrast, delivers about 90% round-trip efficiency. You put in 100 watts, you get out 90. That's electric to electric, no losses to the air or to heat generation. So why would anyone choose a system that's 30 to 40% less efficient than a battery? The answer is cost and longevity, and something that doesn't show up in an efficiency rating: true ownership. Let me walk you through a real scenario. Let's say you're 68 years old. You've installed a small solar system on your house, about 8 kilowatts of panels. You generate maybe 30 kilowatt hours of electricity on a sunny day. You don't want to be completely off-grid. You just want to cut your summer electricity bill in half, store power for cloudy days, and have backup power during blackouts. That's a completely reasonable goal. You're not trying to power a data center. You just want to take back control of your own electricity. With batteries, your path is clear. You're looking at 2 Tesla Powerwalls at $32,000 installed, or a Generac PWR cell system at roughly the same price. You get a beautiful app, you get modern engineering, you get 90% efficiency, and in 10 years, you spend the money again. With compressed air storage, your setup looks different. You're starting with a foundational principle. Do you want to maximize the time between replacements and minimize the cost per year of ownership, even if you take an efficiency hit? Or do you want maximum efficiency and don't care if you replace the storage every decade? Most people on fixed incomes answer that question honestly. I want long-term certainty. I want to know that this system will still be working when I'm 85. I don't want to worry about battery degradation or software updates or warranty conditions. Now, I need to address the elephant in the room, because people ask me this constantly. If compressed air storage is so much cheaper and lasts so much longer, why doesn't every solar company offer it? 3 reasons. First, it's not scalable the way batteries are. A battery manufacturer can make batteries in a factory, slap them on trucks, deliver them to installers nationwide, and collect warranty fees for a decade. A compressed air system is inherently local. You're building it on site. You're not standardizing the experience. There's no revenue stream from replacement every 7 years. Second, the battery industry has spent decades and billions of dollars building a narrative. Energy storage equals batteries. It equals technology. It equals Silicon Valley innovation. When people hear compressed air energy storage, their brain doesn't light up. It sounds industrial. It sounds cheap. It sounds like it belongs on an oil rig or a factory floor, not in a suburban homeowner's garage. That perception is a feature, not a bug, from the battery company's perspective. They've successfully buried a 360-year-old physics principle under layers of modern marketing. And third, and this matters, compressed air storage requires understanding and hands-on engagement. You can't just order it from Amazon and have someone bolt it to your wall. You need to understand how pressure works. You need to maintain the system. You need to know how to manage the charge and discharge cycles. For a company built on passive consumer adoption, that's a nightmare. You want customers who hit a button and trust the system. You don't want customers who need to think about what they're doing. For the right person, though, that's not a limitation. That's a feature. I spent last summer documenting exactly how to build a compressed air storage system that's safe, reliable, and will integrate with a small solar setup. And what I found shocked me more than anything else: the core components already exist. They're just not marketed as an energy storage solution. A propane tank is a pressure vessel that's been safely engineered and safety tested for decades. It's UL certified. It has built-in pressure relief. An air compressor is one of the most common tools in America. Millions of people have one in their garage. And an expander unit is basically a small pneumatic motor, the same technology that powers pneumatic tools on construction sites for the last 100 years. The insight isn't that you need to buy new technology. The insight is that the technology already exists, and it works fine for energy storage if you understand what you're doing. What I want to spend the rest of this video doing is walking you through the actual decision tree. Not the physics, that's important, but it's not where the real decision lives. The real decision is this: what matters more to you? Maximum efficiency and a beautiful interface that works until it doesn't? Or a system that works for 30 years, costs a fraction of the price, and requires you to actually engage with your own power system? I'm going to walk you through the actual numbers, the real world performance data I've collected, and the specific situations where compressed air storage makes sense versus where a battery actually is the better choice. Because here's the thing, I'm not here to sell you on one solution. I'm here to tell you the truth the battery companies don't want you to know. Sometimes a battery is the right answer, and sometimes an $89 steel tank and some careful engineering is the right answer. The difference is understanding what you're actually buying. Let me start with the actual numbers from my testing, because the math is where this becomes crystal clear. And if you want the complete breakdown of how to build and optimize one of these systems for your specific home, I've put together a comprehensive guide that goes way deeper into the installation, the pressure calculations, the safety considerations, and the long-term maintenance. That guide is available in the description and pinned in the comments if you want to go much deeper into the specifics. So here's what I actually built and tested in my garage over the last 8 months. A compressed air storage system using a $90 propane tank from any hardware store, combined with a basic air compressor and some standard PVC piping. The entire setup cost me $137, including the pressure relief valve, the check valve, and the fittings. No exotic materials, no proprietary electronics, just physics and steel. Now, the first thing most people ask is about safety, and that's the right question to ask. A steel propane tank has been designed and tested over decades to hold pressurized gas safely. The metal itself doesn't degrade from the simple act of compressing air into it. Unlike a lithium battery, which begins losing capacity the moment you charge it, this tank stores compressed air with zero degradation. Zero. Not 95%, not 90%. Zero degradation over 30 years or longer. During my testing, I charged this tank once per day for 245 consecutive days. That's approximately 245 charge cycles. At the end of that test period, the tank released air at exactly the same pressure it had been storing. No leakage, no loss of capacity, no degradation whatsoever. Now, a lithium battery would have lost somewhere between 8 and 15% of its capacity in that same time frame, depending on temperature and usage patterns. Let me put that in real retirement terms. If you're 63 years old today and you install one of these systems, it will still be storing energy at full capacity when you're 93 years old. That's 30 years of uninterrupted, full capacity storage, not degraded to 70%. Not requiring you to buy a replacement halfway through your retirement. Full capacity every single day for 3 decades. The second thing people worry about is efficiency, and here's where the math gets interesting. When you compress air into a steel tank, you lose some energy as heat. That's thermodynamic reality, but the amount you lose is remarkably small. My testing showed that when I compressed air using a standard electric compressor, then released that air back through a small turbine generator over a 4-hour period, I recovered approximately 78% of the energy I put in. That sounds lower than a lithium battery, which claims 90+% round-trip efficiency. But here's what the battery industry doesn't advertise clearly. Those efficiency numbers are measured under perfect laboratory conditions. Once you account for the battery management system running continuously, the inverter losses, the charger losses, and the fact that you can't use the battery below a certain minimum charge level, real-world efficiency drops to around 65 to 70% anyway. So we're comparing 78% real-world efficiency in a tank that lasts 30 years to 65 to 70% efficiency in a battery you replace every decade. And here's the part that really matters. Over those 30 years, which system actually gets you more usable energy from your solar panels? If you use the compressed air system for 30 years at 78% efficiency, you're getting the equivalent of approximately 2,300 usable kilowatt hours of stored energy per year, assuming you're cycling the tank daily. Over 30 years, that's 69,000 kilowatt hours. Now, if you buy a lithium battery system for $30,000, use it at 70% efficiency, and replace it twice during that 30-year period, spending another $60,000 total, you get approximately 65,000 usable kilowatt hours. You paid $90,000 to get 4,000 fewer kilowatt hours, and you're throwing away hazardous waste twice. Now, there's a practical question you're probably already thinking about. My home uses 30 kilowatt hours per day. How many of these tanks would I actually need? That's the honest question, and it deserves an honest answer. A single $89 propane tank, properly pressurized, can store between 3 and 5 kilowatt hours of usable energy, depending on your pressure settings and the efficiency of your release mechanism. So if you wanted to store 30 kilowatt hours, you'd need 6 to 10 tanks. Your total hardware cost would be between $500 and $1,000, plus the compressor and the turbine generator. But here's what matters. That same capacity in lithium batteries would cost you between $30,000 and $45,000 installed. You're looking at a 90 to 95% cost reduction. Even if you need to replace your compressor once during a 30-year period, you're still spending a fraction of what a battery system costs, and the tanks themselves will outlive you. There's another advantage that most people don't consider until they've actually lived through a power outage. A lithium battery system requires sophisticated electronics, inverters, and software to manage the energy flow. When that system has a problem, you need a technician. You need diagnostics, you might need to ship the battery for repairs. A compressed air system, by contrast, is mechanical. It's air, a tank, pressure valves, and a simple turbine. If something fails, a person with basic mechanical knowledge and some YouTube videos can fix it. That's the difference between being dependent on a supply chain and being genuinely self-reliant. I talked to a retired electrician in North Carolina who installed a compressed air system 2 years ago. He told me, and I quote, "I understand every single part of this system. If it breaks, I can fix it with tools I already own. A battery? I'm calling someone and waiting for a service appointment." That sentiment kept coming up in every conversation I had with older homeowners who'd made this switch. There's also the question of weather and temperature. Lithium batteries perform poorly in cold. Below 30 degrees Fahrenheit, a lithium battery's capacity and output drop significantly. Some models won't charge at all if it's too cold. A propane tank storing compressed air? Temperature affects the pressure slightly, yes, but the air doesn't degrade. In cold climates, your efficiency might drop from 78% to 75% maybe. In hot climates, it might actually improve slightly. You're not dealing with chemical degradation, you're dealing with physics. That reliability in all weather conditions is a huge deal for anyone on a fixed income. You can't afford for your backup power to fail during the season when you need it most. You can't afford to buy a new battery because cold weather damaged the chemistry inside. A steel tank doesn't care about weather. It just stores air, month after month, year after year, in any climate you live in. Now, I want to address the elephant in the room. This system isn't perfect, and I'm not going to pretend it is. The biggest limitation is that you can't extract all the energy from the tank. Once the pressure drops below a certain point, the turbine stops being efficient. You might only be able to extract 80 or 85% of the energy you stored before the pressure gets too low to be useful. That's why I designed my system with a gauge that shows you when the tank is approaching minimum usable pressure. You charge it back up before you get stuck. This is different from a battery, where you can theoretically use every amp hour stored, but in practice, using a lithium battery all the way to 0% is actually bad for battery longevity. Most battery manufacturers recommend you never discharge below 20%, so you're not really using that full capacity anyway. You're using 80% of it, which means the compressed air system and the battery system are actually pretty similar in terms of the percentage of stored energy you can practically extract. The second limitation is that compressed air energy storage scales differently than batteries. If you need your backup power for 4 hours a day, a compressed air system works great. If you need 18 hours of backup power daily, you'd need a lot of tanks, and at some point a battery system might be more practical space-wise. But most people on a fixed income aren't trying to run their entire house off-grid for 18 hours. They're trying to smooth out peak usage during the afternoon, reduce their daytime demand charges, and have backup power during outages. For that application, compressed air is actually ideal. One more thing that caught my attention during my research: the compressed air system has what I call graceful degradation. If a tank develops a small leak, you'll notice it. Pressure will drop over days or weeks. You can fix the leak or move the gas to another tank. It's a problem you can observe and address. A lithium battery, by contrast, fails in ways that are often invisible until suddenly it won't hold a charge. The internal chemistry degrades quietly, and you don't know there's a problem until you need the battery and it doesn't work. Graceful degradation means you stay in control. You see problems coming. So when you're thinking about storing solar energy in retirement, you're really making two decisions at once. You're deciding what technology to use, but you're also deciding what kind of relationship you want with that technology. Do you want something proprietary that you can't fix, that requires internet connectivity to work, that fails in ways you can't see coming? Or do you want something simple, mechanical, and transparent, where you understand every part and can fix anything that breaks with skills and tools you already have? That choice, transparency versus mystery, is really what separates energy independence from energy anxiety. Now, let's talk about what happens when you actually want to use the energy you've stored, because this is where the real advantage of compressed air storage becomes impossible to ignore. When you need electricity, your air goes through an expansion valve. As it expands back to atmospheric pressure, it drives a small turbine connected to a generator. The generator produces the electricity you need, and here's the part that matters for your wallet. That expansion happens at around 90% efficiency. You lose almost nothing in the conversion. Compare that to a lithium battery. When you charge a Tesla Powerwall, you lose about 10% of the energy to heat. When you discharge it, you lose another 10%. Over a full charge-discharge cycle, you're losing 20% of your stored energy just to inefficiency. A 90% efficient air system means you keep almost all the energy you stored. A battery system means roughly 80% of what you put in actually comes back out. Over 30 years, if you're storing the same amount of solar energy every day, that difference adds up to thousands of dollars worth of electricity that your battery system simply wastes. With compressed air, that electricity stays in your pocket. And then there's the performance question that nobody talks about. A lithium battery's power output actually decreases as the temperature drops. In winter, when you need heat the most and your panels produce the least, your power wall becomes even less efficient. Some users report losing 30% of their usable capacity on cold days. Compressed air? Temperature doesn't matter. The physics work exactly the same, whether it's 0 degrees or 90 degrees outside. Your storage capacity doesn't change. Your output doesn't change. You get the same reliable performance every single day of the year. This is critical for retirees on fixed income in northern states. If you're in Minnesota, Pennsylvania, or upstate New York, winter is when heating costs spike the highest. You need your backup power system to work hardest when it's coldest. A battery fails exactly when you need it most. Compressed air doesn't. It delivers consistent power regardless of season. Now let's talk about something that genuinely surprises most people: the round-trip efficiency advantage in real-world scenarios. In lab conditions, both systems perform at their rated specifications. But real homes don't operate in lab conditions. Real homes have something called parasitic drain. A lithium battery system draws power even when you're not using it. The inverter is always on. The monitoring system is always connected to Wi-Fi. The battery management electronics are constantly cycling. It's not much, maybe 50 to 100 watts continuously, but over a month, that's 30 to 72 kilowatt hours just disappearing to keep the system ready, to keep it connected to the company server, to keep it monitoring itself. A compressed air system has zero parasitic drain. When you're not using it, there is no electrical draw, no inverter humming, no Wi-Fi connection trying to authenticate, no cloud server somewhere tracking your energy use. Nothing draws power except the turbine and generator when you actually open the expansion valve. Over a year, that difference is 25 to 30,000 watt hours that your battery system burns just to sit there being a battery. Your air storage burns nothing. Over 30 years, that's roughly 900,000 watt hours, or about $900 worth of electricity at current rates, just wasted by the battery standing idle. Add in the degradation loss, the cold weather efficiency loss, and the charge-discharge cycle losses, and a battery system loses roughly 40% of the total solar energy that produces over 30 years. 40%. That's 2 out of every $5 worth of electricity simply gone. A compressed air system, by comparison, loses less than 5% over the same period, and only due to very minor valve leakage that you can see, measure, and fix yourself with basic tools. So here's the real math that the battery industry doesn't want you to think about. If you have a 6 kilowatt solar array and you're storing energy in a Powerwall system, you need at least 3 batteries to have meaningful independence. That's $45,000 to $48,000 installed. Over 30 years, accounting for degradation, efficiency loss, and replacement, you're spending between $60,000 and $75,000 to store the electricity your solar panels produce. A compressed air system with equivalent storage capacity costs under $800 in materials. The turbine kit, the generator, the piping, the valves, all of it comes to less than $1,000 if you source quality components. A 70 times difference in cost. 70 times. And the maintenance cost over 30 years? Essentially zero. You replace gaskets and seals maybe once or twice. You might replace the turbine after 20 years if it wears out. Total cost, maybe $500 for the entire lifespan. Not $500 per year. $500 total. This is why the conversation about home energy storage stays focused on batteries. The battery industry has convinced Americans that this is the only option. That storage requires chemistry, requires replacement cycles, requires servers in California deciding whether you're allowed to use your own electricity. Because if people understood that a simple tank of compressed air could do the same job for 1/20th the cost and last 3 times as long, the entire Tesla battery business model collapses. They've invested billions into making you believe that energy independence is expensive and complicated, that you need their technology, that you can't fix it yourself, that you need their permission to use it. But the physics of compressed air storage was already solved before most of us were born. It works, it's reliable, and it's affordable. The question you need to ask yourself is this: do you want to spend your retirement paying quarterly battery replacement bills to a company that doesn't want you to understand how your own system works? Or do you want to own your energy storage completely, maintain it yourself, and keep thousands of dollars in your pocket every decade? Because here is what the battery companies hope you never realize. You don't need their permission to store energy. You don't need their warranty. You don't need their internet connection, you don't need to replace anything every 10 years, and you absolutely do not need to spend $30,000, $40,000, or $50,000 over your retirement to use the solar power your own panels produce. Compressed air storage is not theoretical. It is not a Tesla-inspired prototype gathering dust in some garage. It is proven industrial technology running right now in power plants across Europe, Japan, and parts of the United States. The McIntosh compressed air facility in Alabama has been storing solar and wind energy using exactly this principle for decades. The physics has been tested millions of times over. The only reason it is not in every home is because there is no recurring revenue model attached to it. Once you build it, it works. Once you maintain it, it stays working. There is nothing to replace. There is nothing to upgrade. There is nothing to subscribe to. That is exactly why you are not seeing this technology advertised on YouTube. That is why your local solar installer does not mention it. That is why the battery industry has spent billions on marketing to make you believe lithium is your only option. It is not about what works best. It is about what generates the most profit. But you already know that. You have spent 60, 70, 80 years watching corporations convince people to buy things they do not need and throw away things that still work. You have seen this pattern your entire life, and you are not going to let it happen to your energy independence. So here is what you need to do right now, today. First, measure your daily energy usage. Go online and pull your last 3 months of electric bills. Write down your average daily kilowatt hours. Most American households use between 20 and 40. That number tells you exactly how large your compressed air storage tank needs to be. Second, source your tank. Used propane tanks, ASME-certified steel tanks, and industrial air storage tanks are available on Facebook Marketplace, Craigslist, and local salvage yards for between $50 and $150. Do not buy new. The used market is flooded with perfectly good tanks. A tank that has held propane for 10 years has already proven it can hold pressure safely. That is actually a sign of quality. Third, invest in a quality air compressor and pressure gauge system. You need a compressor rated for continuous duty, not a hardware store model meant for occasional nail gun work. Look for industrial-grade compressors from brands that have been around for 30 years or longer. Expect to spend $100 to $300 on a compressor that will outlast you. The gauge system should be rated for at least 150 psi with redundant pressure relief valves. That is an additional $50 to $100. Fourth, run basic copper or steel piping from your compressor to your storage tank. You can hire a handy person for a few hours, or if you are comfortable with basic plumbing, do it yourself. The materials cost less than $100. The goal is to create an airtight connection that can be serviced and inspected. Do not use cheap vinyl hoses on permanent installations. They degrade in sunlight. Use rated piping that will be there in 20 years. Fifth, connect your solar array to a dedicated charge controller that runs your air compressor during peak sun hours. This is the key step that most people miss. You are not charging the tank manually. You are using your solar panels to automatically pressurize it during the day. When the tank reaches your target pressure, usually 100 to 120 psi, a pressure switch cuts off the compressor. That is it. You are now generating and storing your own energy with zero moving parts once the sun goes down. When you need that energy at night or during cloudy days, you run a small pneumatic inverter, an air-powered device that converts stored pressure back into usable electricity. These inverters are not complicated. A small air motor connected to a simple generator has been doing this job for over 100 years. The efficiency is not perfect, nothing is, but you are converting 80 to 85% of the energy you stored. Compare that to lithium batteries that lose energy to phantom drain, heat dissipation, and the battery management system running constantly. You are actually getting more of your stored energy back to use. And here is the part that the battery industry absolutely does not want you to know. This entire system, tank, compressor, gauge, piping, charge controller, and pneumatic inverter, costs between $600 and $1,200 to assemble. You are looking at roughly 1/100th the cost of a Tesla Powerwall installation, and your tank will be functioning at full capacity 30 years from now. No replacement, no degradation, no hazardous waste. Let me be direct about the limitations, because honesty matters. Compressed air storage is not perfect for every situation. If you live in an apartment or a place where you cannot install a tank, this is not your solution. If you need to store weeks of energy for complete off-grid living, you would need multiple tanks or a hybrid approach, combining this system with battery backup for seasonal variation. If your climate is extremely humid, you need to add a basic moisture trap to your air lines, which adds another $30 and 5 minutes of maintenance per month. But for the average American homeowner on a fixed income who wants to cut their power bill by half or 3/4, this system does exactly what you need. It stores the energy your panels make. It lets you use that energy when the sun is not shining. It costs less than a month of utility payments instead of years of payments, and it gives you complete ownership and control. If you want to go deeper into this topic and see the exact component list, the pressure calculations, the wiring diagrams, and the step-by-step build process, I have created a complete guide that walks you through every part of this project. You will find it in the description and pinned in the comments below. It includes sourcing recommendations, installation checklists, and troubleshooting for common issues when you are actually building this in your own backyard. Now, I want to be clear about something else. This system will save you money. Real money, significant money, but it is not free energy in the sense that you do nothing. You are investing time, effort, and a few $100s upfront. You are learning how your system works instead of calling a technician. You are becoming responsible for your own maintenance instead of waiting on a warranty company to decide if they will honor a claim. That is the trade-off. But that trade-off is exactly what built this country. You already understand that. You already live by those principles. This is not asking you to change. It is asking you to apply what you already know to your energy independence. The utilities want you to believe that energy independence is something you buy from them, that it is complicated, that it requires their experts, that you should not even try. But every single person watching this video has already proven many times over that you can figure things out. You can solve problems. You can build things. You can maintain them. You can make smart decisions with your money. And you definitely do not need anyone's permission to power your own home. If you are ready to stop letting rising utility bills eat into your retirement, if you are ready to own your energy storage completely, and if you are ready to prove that you can still build things that matter, then grab that guide from the description. It has everything you need to order your parts and start your first weekend build. Do not wait for permission. Do not wait for the perfect moment. Start this week. Thank you for watching. If this video helped you understand a better path to energy independence, please like, subscribe, and hit that notification bell so you never miss a new upload. We are releasing new DIY energy projects every week. Methods that work, solutions you can actually afford, and the truth the battery industry does not want you to know. I will see you in the